Hello. So previously I made a video where I integrated AI into a project and that was through an API. But in today's video, we're going to talk about concepts of AI like embeddings, what are they, how to create them, also vector databases, and finally touch up on frameworks like Langchain. I'm very excited to share these concepts as I integrate on the projects and learn about them. So let's get started. Before I go into the embeddings, since they are part of natural language processing, I want to say a few words about that. And natural language processing is a field of artificial intelligence that focuses on the interaction between computers and humans so that computers are able to understand humans through a natural language. So the objective of NLP is to read, decipher, understand, and make sense of this human language in a way that's valuable for computers. And what it uses to, translate this human language is computational and mathematical methods. As for the text embeddings, to put it simply, it's just another NLP technique that converts textual data into numerical vectors that can be processed and read by machine learning algorithms, especially large models. So to take a look at a simple example, on the left here we have this three words, and on the right, which is the output, we have something that resembles, as we say in coding, an array of numbers. And each number here represents a vector. And this whole output, this whole array that we're seeing represents a point in a high-dimensional latent space. And to understand what is this high-dimensional space, we look at this Cartesian coordinate system, which you probably have seen it in your algebra class. And here we only have two dimensions. We have an x-axis and y-axis. And if we were to imagine that these points on the graph are actually words, that's how embeddings would work. But instead of having two-dimensional, we have what I mentioned before, this high-dimensional space. So that's why instead of us getting just a 5 and a 2, 5 for x-axis, 2 for y-axis, we have this long array of numbers, and it could go up to like hundreds. And just to follow the example, let's say if this one is a pen, we use it to denote pen, and then we have a pencil. If there were a third word, something like a book, that's a little bit different than pen and pencil, it's not a writing tool, it would be further away from this tool, because also the distance matters when it comes to words or phrases. So the words that are more semantically similar, they are placed, I guess their distance is smaller than words that are different. So not only does the vectors or embeddings that are generated capture the semantic meaning, it also captures the context, because there are some words that could have different meanings in different contexts. So that's why there's a lot of things that go into understanding a meaning of every single word or like a phrase. That's why we have so many numbers that get generated so that computers can understand it. And there's formulas to calculate how similar the words are. They're not just the distance. And the biggest use case of that would be like a search. For example, when you type in the Google search, the results that you're getting are not just exact match of the words that you typed in. You're also getting results that mention text that has a similar meaning to help you get the best result. So now let's take a look into methods for creating embeddings. There are various different kinds of methods, and I'm gonna mention two of them. One is developed by Google, one by OpenAI. So BERT, that's worked by researchers at Google. It is a powerful pre-trained contextual embedding technique. It does stand for bidirectional encoder representations from transformers. I'm going to explain that. That sounds complicated, but basically it's built on a transformers architecture, and as I mentioned, it's used for generating embeddings. As a matter of fact, both of them, GPT and BERT, are based on transformer architecture. And when it says bidirectional, what it means is that when it's generating embeddings, it takes into considerations of context of a word, both from the left side or the right side. So let's say if we were creating so I'm gonna zoom on this, a context for this word. So the embeddings would also look at this word and the word that's coming after. So that's bidirectional. As for GPT, GPT is a name for like a series of models. We've heard about just GPT, GPT-2, 3. They also use transformer architecture, as I mentioned, and they're mostly known for generating text, although they can also produce contextual embeddings. And for example, so if you type in your prompt in ChatGPT, it gets converted into embeddings that is after served into a model that returns output. So then that's the response you get back from the ChatGPT or from the API when you're using OpenAI API instead. So this form of embedding methods transform textual input into a numeric form, and it allows models to like process immense volumes of data. So it's like an efficient method, and also gives them understanding of this natural language. Now let's take a look at some code samples before we generate embeddings ourselves. And even within OpenAI, there's different ways of creating embeddings. For example, you can use their embeddings endpoint in their API. There's also a Python library. They have a Node.js library. But I believe for all these libraries or to use their services, you still need to create an API key. And there's also like a pricing involved based on the usage or depending on the plan that you have. But I think the key thing here and how this like embeddings model, the latest one that they have, as you can see, there's like scores for performance. So in terms of performance, it's better than the other models. And in terms of also pricing, you can see that DaVinci was the model before. And as they are saying, it's at a 99% lower price. And the price point is one of the things that has that's my opinion, resulted in them becoming more accessible and used by a lot of companies and indie hackers, developers. So yeah, let's take a quickly look at the pricing, what it is looking like. So embedding 3 large, it's priced, this is priced in dollars, over 1K tokens, and that would be around, I think, 700 words. So that's what the pricing like. I just wanted to go over that. And as you also have in this blog examples of embeddings and software that's using their embeddings API for search. And one of them is Notion. So if you want to like search, for example, I use Notion to plan my content and write down things that I learn, and I guess they're using to search through different documents. So I find it really convenient, and if you are interested also for trying it out, you can use the link in my description. All right, let's try generating embeddings, and we're gonna make a call to OpenAI API. We are going to use embeddings endpoint and also the curl command to make the call from terminal. So I have just terminal open. We're going to pass the header options for the API, like content type and authorization. So this is required. I'm going to replace this OpenAI key with my actual key, and you can get that on OpenAI dashboard. All right, once I have that, I'm gonna update the input text here. Hopefully it realizes that the context is YouTube, and let's just press enter. So here we also pass the model that we're using. So that's our embeddings, and it returns, I guess, the object type, and then in the data, it has embedding, and then embedding field itself has an array. So search is one of the use cases that I mentioned that could be for embedding, and one of the methods of search is nearest neighbor search. So you find, it's a way of finding similar documents when you run a query on a vector and you also fetch its nearest neighbors. That means that, like, let's say you get back n number of neighbors. That means that those are the most similar documents tags to the query that you have. For document retrieval, that would be the Notion example that was on OpenAI's blog. Once again, you fetch the documents that match your query or are the closest to the prompt and query that you are looking to search for. As for text classification, that's also another use case for embeddings, and a good example of that would be like in email providers. They usually, when the emails come in, you might have folders for promotions, spam, and your emails as a text, they get classified. And if, let's say, you are the one implementing a text classification, the way you would do is that you would compute the embeddings. Let's say you have a set of documents that you can use for training. So you compute embeddings of them, and then you use a machine learning algorithm to train a classifier. For example, you can do deep neural networks. So once you have a new document, then you compute the embedding of it, and then you use this train classifier to predict its category. So should it go to the main inbox, should it be marked important, and other categories. So we went over the use cases of embeddings. Now the next question is, do you need to pass large amounts of data to the AI and it to answer questions based on that large knowledge? For example, let's say you are, or like a company is building an internal website where they take the company documentation, internal docs, and then want to create a chatbot where employees can ask questions and the chatbot would respond to the question and also pinpoint on where they can find more information or which link they have to go to, things like that. So when this is the use case, you need to implement some kind of long-term memory into this AI conversations, and it can't just be done by calling an API. And the reason for that is API so does, if you type some things into ChatGPT, they have a window. If you have experience maybe of putting a very large text in the ChatGPT, it would tell you maybe that you're over the limit, and same is the case for API. That's like it counts certain number of tokens and you can't go over that. And the reason because of that is that this large language models, they have a context window, so it's limited on how big this context could be. That's why you can't make an API call and on every single call pass your company documentation and then return an answer for that. So that's not the way of doing it. So how do people approach, I guess, this issue and introduce this memory? There's few ways of doing it. The first one, sliding context window. That would be if you do some leet code, if you know the sliding window algorithm. It's kind of a similar scenario. So let's say you have a conversation and you only pass, not to go over the limit. Once you make an API call, you only pass the last X amount of messages, maybe 5, maybe 10. So you just keep it down to the token. But that's not the best approach because eventually the AI loses the context, which is the previous messages or tags that you had. So then the second one, this is where embeddings come in. What you can do is then you can search the most relevant embeddings to your whatever the question is, and then pass this similar embeddings to the AI. So that way this AI assistant has some kind of long-term memory. So because it remembers the parts of the conversation that are most relevant or like semantically similar. And where you can save this embeddings is in a database, specifically a vector database. So I don't think we have, let's see. So maybe this internal documents that I mentioned, you store them, and as we saw, this is what embeddings look like. So you have a text, you have this bunch of numbers, you can maybe save, like, you can have different fields, but it would be, you can save both, let's say, text and this embeddings, and then you can do your search against this vector database. We're going to go over what you can use. I think one of the popular ones is Pinecoin, but you can achieve that with other databases, for example, Supabase. And finally, there's a third method is summarization. So basically, instead of passing the whole conversation, you use an AI to summarize it for you, and then or you keep the summary of the previous conversation as it grows, and then when you ask more questions, you pass this summary as well. And then once again, there's few ways of generating the summary, but for summarization, also for doing search and those kind of things, there's this library called Langchain that has this built-in functions that you can just import the library. It has a Python version and it has a JavaScript version, so you can install it into your project and then use the functions to easily achieve these methods and don't have to write, I guess, the codes for certain things you'd achieve in AI from scratch. And it can also help with documents. Let's say if you have a large document, you want to do some chunking or handle it. So overall, what Langchain does is it's a framework that helps you build LLM, large language model based applications. I will create a new Next.js application with this command, and we'll implement summarization following Langchain documentation, but we won't be using much of like Next.js specific features. So if you understand JavaScript, I think you should be able to follow along. This is the command, and it will ask if you don't have installed the package for the latest version. If you want to install, so I'll go ahead and press yes. Name of the project, I'll name it to VectorDB tutorial for reference, and we're not using TypeScript in this one. Tailwind CSS, this is just for styling. We can go ahead and say yes to it, yes to source directory, and app router as well. All right, and then after the project is created and we'll redirect to the project folder, we would have to install Langchain, and also this specific example uses Anthropic, but we're gonna switch out Anthropic with OpenAI. And now we can navigate to the project, so that would be CD and the project name. And open the project in the ID of your choice. I'm using VS Code. Okay, let's install Langchain. I'm gonna go inside here, open up a terminal. So Langchain / OpenAI. We have to install like the core functionalities of Langchain separately. So we can press enter on that and look at what's going on here. So on this summarization document at the top in the introduction, they also mention like this issue of having a context window limitations, and summarization being like using this way good use case for summarizing long documents. It doesn't have to be video. You're gonna need chunking even for like PDFs and other long formats. So what it's doing is using the search API loader, it's fetching a video from YouTube, passing a video ID. So then this loader, it's loading it, then we're taking the text splitter and it's dividing into chunks, and the size of the chunk is 10,000 characters maximum. But then it's calling this an Anthropic instance. We're gonna do OpenAI. After that, we have a summary template. So basically, it's giving like an explanation on how it should analyze or like summarize YouTube videos. And the reason we passed this prompt in the beginning is, as I mentioned, Langchain is also used to build context-aware applications. So every time we call this API, it will have this context in mind. So yeah, going forward, then there's a chain created, and this documentation chunks, I guess, is passed to the chain, and that chain returns a summary. So let's try it out. I am going to copy this and modify it. And for that, we'll first create an API. I'm going to go into source folder, inside the app, create new folder API. So this naming for API is Next.js specific, so make sure you name that. And for the API like path, let's do API slash summarization. So we need a new folder for that. And then we have to name, this one would be the file route.js. So in here, let's first paste that in and make modifications. This would be, it's called chat OpenAI. And here we need to pass, so we update this instance of OpenAI, and we need to pass an OpenAI API key. So you can paste it in here, but I do not recommend it, because if you upload it to GitHub, then or any other like source code manager, your keys could be exposed. So it's best to save that in environment variables, and then this package, actually, if you name in your environment variables OpenAI API key, it's going to read automatically, so you don't need to pass this separately. And I'm going to show you guys how to add those. We need to create a new file. Let's name it .env.local. To create one, go to OpenAI, create a new account, go to their dashboard. You can select API keys and create new secret key. Paste. Once you save your key, we can change this to process.env OpenAI API key. And update the model name, because it has to match one of the models of OpenAI. And this has to be a function, so export async function. It's async post method. So as for the search API loader, even though they don't have mentioned here, the API key for it is required, because it is a separate API from, I guess, OpenAI or like. And if you pass API key, you would be able to use it, but I'm not focusing on like the searching or scraping in this video, so I'm not gonna go along. And also, you can sign up. They have this is the link, and I believe the first 100 requests are free. But instead of the search API, we are going to pass our API like a text, so it's gonna summarize that one. And first, I'm going to just put text here, and then after that, I am going to define it in as a parameters that we can pass to post. So we are going to have to create a new document, as the text splitter takes in document. So where we have split documents, we're passing docs. Instead of passing docs, it would be new document. And the documents are constructed by page contents. Let's save that. We can remove this piece. And instead of console logging the result at the bottom, we're going to return as an API response. For that, we need next response from next server. And return next response dot JSON. That would be summary. And one thing that I missed, that this actually has to be a array, since this splits documents function is expecting that. But if we test it on just a small text like this one, since it's supposed to generate summaries from podcasts, we'll get return that this is not sufficient for the summary, it's not a podcast. So that's why I'm gonna take Huberman Labs, one of the podcast episodes, and get the transcripts. On this website that I found, we can select like a raw text, and I'll pick, let's do this one. So I'll paste it in the Postman, which is what I would like to use for testing APIs. You can make a request to the API also using curl command like we did earlier. But so I think the UI of Postman is pretty nice. So for the body, I'm going to select form data. For the key, I'll do transcript. And then in the value, I will paste this in here. And our API has to accept this, so we need to take in request. I don't think we need a result. Form data equals to await request that form data. Let's do constant text equals to form data.get, but I named it transcript. And we can remove this one. Let's save this. Let's go here. Make sure you have selected post and send. Oh, I didn't indicate the URL, which we should be running our application first to be able to testing it. So that's our URL. And if we go here, then we have API and then summarization. That's our endpoint. Let's see what it's saying. So because it is creating a chain, it would console log more details. So entering LLM run with input. So we have this input that we passed. And let's see the summary. So it summarizes what the discussion is about. Also create a form that takes in, you can paste the text and it would generate and display the summarization based on that. So it's a little bit more dynamic. And we have the code for the current page in here. So if you go to localhost 3000, this components is coming from here. And we can remove just pretty much everything. In the text area, we will pass this transcript, because that's what the value that we want to take there is, and also just number of columns. As for the class names, if you're wondering where the styling is coming from, These are Tailwind classes, so CSS I haven't written. It's like utility classes, so it's automatically applied. So this stands for width full, height, and then padding. So that's our transcript here, and then we have a button that says generate. Let's make the code bigger. Okay, so now we want to connect once this is pasted the form to the API. We can do that using the form prop action, and we define method that equals to post. So what's basically the form is going to do, if there's any other inputs here or text area, it's going to take the name, in this case transcript, and then it will take the value the user has entered. So the value would be saved as a transcript being the name of the field, and it will come through this form data here. And once we get that, we'll have the value stored inside text. And that's how it is. Only thing we have to do is inside action, we have to pass the endpoint. So that's it. API summarization. So we don't have any loading indicator in the UI, but we can see in the browser that it's loading. We can also inspect our log before it gets loaded. And that's our summary displayed on the screen here. It's saved inside the summary object as we did pass it in that way, and then the rest is just the text of the summary. So we did the summarization, now we can move on to the embeddings, and actually it is a pretty simple process, as we just need to create an instance of OpenAI embeddings and then just call the function and pass our text. First we can do the import, it's called OpenAI embeddings, and you can do it also from the OpenAI package, but we're going to use Langchain in this case, and we can do that after we get the text. So maybe somewhere in here I'm going to create a new variable, name it embeddings. And we need to pass OpenAI API key like we did for the chat, so it would be the same key. And we can do, so for the model name, it would be, we have to pick between model names of the embeddings, and I'll get, so then we create a vectors array that's going to save a embeddings that's been generated, and that would be embeddings, embed documents, and we can pass the text array, text is what we named it. Okay, and then let's console log, and let's also just check how big is our vectors. Oh, I'm missing a B in here. Okay, let's save this, and if we try to hit this again, we have the summary, and vectors is very large, so maybe console logging it is not the best idea. So that's our summary. And those are the vectors. So indeed it is a very large array, but yeah, we're able to successfully generate embeddings. And now for the final part, we'll create a database where we will save the vectors that would be generated as a part output of second step, and we'll use Supabase to host that database. As I mentioned before, even on the Langchain website, there's some Supabase documentation to help us get started. But before we dive into that, let's go ahead to the dashboard of the Supabase here. You can create a new project. I'll name this project JS database password. I'm gonna let it generate. Make sure to copy that. We're gonna need it for the setup later. And create new project. This is going to take a few minutes. And before that we can, all right, actually that was faster than that. But before we go back to it, we can install this Supabase library we're gonna need in our project and also Langchain community. So I'm gonna open the code. Let's install Supabase and Langchain community. And we have to run this in the database. So what it will do is it will create tables and also columns on those tables where we will save our documents. So it will name, like, it's going to have a content, metadata that contains information about the document itself. And then we have this embeddings field where we save the vectors. So let's copy. So we can open here inside the project SQL editor. If we paste this and press run, it would make the changes. And if we go to database, this is for visualization. There's a schema visualizer, and we can better see that we have a documents table and all this for fields. So example usage in here, what they're doing is importing Supabase vector store. It's passing an array of the text that is hard-coded. New OpenAI embeddings that will create the embeddings. Also, when running this, we pass the table name and the query name. So this query was defined, the match documents, when we ran this SQL as well. So it's already in the Supabase, and then this function to do a similarity search. So I'm gonna hide this, go back to our project. First, let's do import this. The next step would be defining the URL and the private key. That information you can get inside the project if you click on connect and then select app frameworks. By default here Next.js is selected, but if not, you can select it. We are using app router. So you copied this, we're gonna go back and paste it into our env local. Okay, so we are good to use this. First, we need to create a Supabase client. I'm gonna rename this Supabase client just for readability. And if we run this, it would save the embedding. So let's do that. But instead of from text, we are going to use from documents function. I don't think we need this array, and we are going to pass the documents we had created. So that would be doc summary. comma. But instead of as a client, we're gonna rename the field. So it would be Supabase. Now, if we submit this again, it's gonna call our next API, public, and if you start your variable name dashboard in the table editor and select documents table. And you should see that's our the text, and then we have metadata that contains information like which lines are this text from, and that's relevant because when we're doing search we can use this information. And that's our embeddings. This also can be saved if it's a larger text, saved separately. And right now when we have this chunk size, we're passing 10,000, but if we decrease this number, then this would be saved as multiple rows. And we can try that if we just do 1000 and overlap 100. So now we have more chunks because the size of maximum if each one is smaller. And that would be it for this tutorial. Thank you so much for watching. And I'm also planning to work on parsing PDF summarizations and like a chat with PDF, like a mini project. And it would follow same steps where we upload the PDF, parse the data, convert it to text, divide the text into smaller chunks. Then we create embeddings and store them in the vector store, on which then we can do search and other cool things. So stay tuned, and I'll see you in the next video.